Okay, everyone, we're to the last chapter of calculus. How exciting! And what we're going to be looking at in this chapter is some different applications of integral calculus. So we're going to start with the average value function, average value theorem. So you have to consider if a function is continuous on the interval a to b, a closed interval a to b, then the average, also known as the mean, the average value of that function on that interval is defined by this equation right here, which I'll write for you. F average, so the average function, is equal to 1 over b minus a. You're going to take the integral from with a lower bound of a and an upper bound of b, the integral of that function with respect to x. So one way you can kind of think of this is if you were to graph a function, let's just say here's my function and it looks something like this, right? If I could kind of push down all the mountaintops here and raise up all the valleys to get to kind of a middle point or an average point, right? Let's say when I pushed it up, push this down, I don't know, it would end up about here, and bring this up, it gets here, and I end up with this horizontal function there. That would be the average right there. How else did I say this? This is just kind of give you a sense of it. If you could level out a function until it was just a horizontal line, so that's what I was kind of trying to show you there. The height of that line, in other words, what's its y value? How high up the y-axis does this green line at? That would be the average value for that function. And as I said, this is the formula right there. So it's not too much to figure out or anything. We just have to use the formula. Let's try it. Find the average value of the function f of x, which is equal to x cubed minus 4x squared plus 3x plus 4 on the closed interval from 1 to 4 inclusive. So, of course, we're going to use the formula. I'm not going to rewrite it this time. You can see it right there. So f average equals 1 over b minus a. You know what b and a are, right? That's the interval. So 4 minus 1. Then we're going to take the integral of the function, which is x cubed minus 4x squared plus 3x plus 4 in terms of x, with a lower bound of a, well, a is 1, and upper bound of b, which is 4. And that's it. You solve that and you're done. And you know how to solve that. We can simplify the front, so we get 1 over 3. Now we're going to take the integral here. So x cubed, we raise it up to 4 and divide by the same thing. 4x squared, we raise it up to 3 and divide by the same thing. 3x, we raise it up to 2 and divide by the same thing. And 4 becomes 4x. Lower bound is 1, upper bound is 4. Now, this is kind of a unfortunate question. Not so hard, right? Everything we've done is pretty straightforward. But now we get all these fractions. It's actually kind of ugly here. So we're going to plug 4 in first. So I put 4 to the 4th power, which is 256 over 4, minus 4 cubed is 64, times another 4, we're back at 256 again. But this time it's over 3, plus 4 squared is 16, times 3 is 48 over 2, and 4 times 4 is 16. Minus, now we're going to plug 1 into all these. So 1 to the 4th is 1, we got 1 over 4, minus 1 cubed is 1, 4 times 1 is still 4, 4 over 3, plus 1 squared is 1, times 3 is 3, 3 over 2, plus 4. Okay, once we do all this, I guess we have to do 1/3 times all of that, don't we? So 1/3, 256 divided by 4 is actually a whole number. It's 64. 256 divided by 3, I'm afraid, it doesn't go in evenly. We'll have to keep that. 48 divided by 2 is 24. Then we have our 16 here. And actually, you know what I'm going to do? I'm going to distribute that negative right there. So I'm going to have negative 1/4. Negative negative makes a plus 4/3. Negative 3/2. And negative 4. I've got too many brackets, but that's okay. 1/3. Why don't we bring all the whole numbers? So we got 64 plus 24 plus 16 and minus 4. And with all the other numbers, we need a common denominator. I guess it'd be 12. So minus 12 on the bottom here, we multiplied by 4, so we're also going to multiply by 4 here, and you get 1024. Oh, such big numbers. With the 1/4, you have to multiply top and bottom by 3, so you just get 3 on the top of that one. With the 4/3, multiply top and bottom by 4, you get 16. And with the 2 on the bottom, you are going to multiply by 6, so you end up with 18 on top. Getting close. Add these numbers. So let's see, 24 and 16 is 40. 40 plus 64 is 104. Minus 4 is just 100. And then when we combine fractions, the denominator stays the same. Oh boy. Okay, negative 1024, and then we've got to take away another 3. So we're at 1027. I'm going to skip over to this. We're going to take away another 18. So we're at 1045, and then we're going to add the 16. So you end up at 1029 over 12. And that's actually divisible by 3. I could divide top and bottom of this by 3. I'm going to save a step. When this becomes when I divide them both by 3, I'm going to get a 4 on the bottom here, right? So why don't we get common denominators of 4 on both of these? So I'm going to multiply by 4, I get 400. And I'm going to divide by 3, so I get 4 here. 1029 divided by 3 is 343. So then you have 1/3 times 400 over 4 minus 343 over 4 is 57 over 4. And at last we have our answer. It's 57 over 12. Whoops. And that's it. So again, the hardest part of this was, all the fractions and stuff. It's like a really hard grade 9 problem once we got to here. But hopefully setting it all up wasn't too bad. You've probably forgotten what we're doing because we spent so long doing all the fractions here. So remember, we're finding the average value of the function. Let's do it again. Average value of this function right here on the interval from 1 to 100. So if we plug it into the formula again, you're going to do f average equals 1 over b minus a. Well, it's 100 minus 1, which is just 99. I'm going to start skipping some steps here. And then what we need to do is, from 1 to 100, take the derivative of natural logarithm of x over x in terms of x. Now, how are we going to integrate this? Well, if you look, you have natural logarithm of x, and then what is the derivative of that? It's 1 over x, right? So this is where u substitution might work out very nicely for you here. If we call u ln x, then what's du dx? What's the derivative of that? The derivative is 1 over x. And remember, we want to get the x's on the same side, so we want to bring this dx over. So you'd have that du equals 1 over x dx. Hey, look at that. Now we can actually substitute in here. Instead of writing ln x, I can write u, and instead of writing dx over x, I have dx over x right here, I have du. Wow, so I've just made this a lot easier. Now all I have to do to get f average is still 1 over 99, but I only have to integrate u. That's easy, except for one thing. Remember, I'm not going to put 1 in 100 here. When you do u substitution, you have to change the bounds. So our new upper bound is, remember how to do it? You just stick the upper bound into this expression right here. So it's going to be natural logarithm of 100. And for our lower bound, you do the same thing. You're going to put 1 into there. So you get natural logarithm of 1. But wait a minute. Natural logarithm of 1, e to the what equals 1? E to the 0. So our new bounds are 0 and natural logarithm of 100. Okay, now we can solve this. We're going to keep the 1 over 99 here. We're going to take the integral of u, well that's just u squared over 2, and we're going to go from 0 to the natural logarithm of 100. So 1 over 99, we plug ln 100 in there, so we got ln 100 all squared divided by 2, minus, then we put 0 in there, 0 squared over 2. Well, obviously the 0 squared over 2 is just equal to 0. And we could multiply the 99 times 2, and in our denominator we'll now have 108. And on the top, what we're left with is natural logarithm of 100 all squared. This is not a 2 that you could move out to the front here. That would only be if just the 100 was squared, right? But this is the whole value of natural logarithm of 100 squared. So that has to stay there. There's nothing else you can do. That's it. That's our answer. And it's probably redundant at this point to do another example, but what the heck, we'll do it. Find the average value of this one. So f average equals 1 over b minus a. That's 2 minus 1/2, which is what? 3/2? So we have 1 over 3/2. We'll simplify that after. And we have to take the integral from 1/2 to 2 of 1 over 3x in terms of x. Well, let's simplify a little bit here. So 1 over 3 over 2 basically means the reciprocal of 3 over 2. If you don't understand that, you're doing 1 over 1 divided by 3 over 2, or multiplied by the reciprocal, so you get 2 over 3. So we have 2 over 3 out front, but wait a minute, this 3 right here, that's a constant. We can move that out front too. So we actually have 2 over 3 times 3. And what's still left inside the integral is just 1 over x dx. That look familiar? It should. If you take the integral of 1 over x, remember what you get? You get ln x, natural logarithm of x. So we have 2 over 9 when we multiply the 3 times 3. And then we have natural logarithm of the absolute value of x from 1/2 to 2. So 2 over 9. Now, let's see what this equals. Natural logarithm of 2, you don't need to put the absolute value signs because 2 is obviously a positive amount, minus, plug 1/2 in there, natural logarithm of 1/2. Again, don't need to put the absolute value signs because it's positive. So this is your answer right here, though you could simplify this a bit. So we're just going to play with logarithms a bit. There's different ways you could do this. Here's how I would do it personally. When you are subtracting the same base logarithm, you can write it by dividing this portion of the logarithm, right? So I can actually write it like that. And 2 divided by 1/2 is the same as 4. So I get 2 over 9 and then the natural logarithm of 4. But then there's something else you could do. I mean, I think this is fine. I don't think I could mark this wrong or anything. The other thing you could do, though, is you could move this 2 over here because of another logarithmic property. You could move that and make that the exponent on the 4. So you could have the natural logarithm of 4 squared. You'd still have 9 as your denominator, which means another way to write this would be natural logarithm of 4 squared, 16 over 9. So I don't know. I guess this one avoids a fraction out front, but you still do have a fraction. You're still dividing by 9. So I don't know which one's really better. You could either have this one, 2 over 9, natural logarithm of 4, or you could have natural logarithm of 16 over 9. I'm not sure at university, for example, if there's one that they would prefer, and if there is one, why it would be one or the other. So I would take both of those. Those are great. All right, everyone. Hope that makes sense, and I'll talk to you next time.